Welcome everyone to another edition of Build Hour. My name's Pranav Deshpande. I'm on the product marketing team here at OpenAI, and I'm joined today by my friend Ilan.
Yeah, hi, I'm Alon. I'm on the developer experience team. Last time I was here, we were hosting the assistance agents build hours. So excited to talk about the real-time API today.
And today he's gonna dive deep into the real-time API with a couple of exciting demos. So let's get into it. And then for those of you who've attended these before, you know that our mission here with Build Hours is to really empower you with best practices, tools, and AI expertise to help you scale your company with OpenAI APIs and models. And today's topic is actually really timely because October has been a great month for audio in the API. If you've been following along, we launched the real-time API at Dev Day SF on the 1st of October. 2 weeks later, we launched audio in the chat completions API. And then finally, last week, we launched 5 new voices in the real-time API, as well as some exciting updates to our pricing. And so we've got a lot of that to cover today. And before we dive in, we did a quick pulse check with the audience in terms of where you were with your journey with building voice AI applications. And turns out we have folks from every stage of the journey. We have people who've built with the real-time API already. So if you have any tips, feel free to drop them in the chat. We'd love to hear them. And I'm sure your co-attendees would as well. But also we have folks who are just getting started and folks who've used other approaches in the past. So we're excited to cover all of that today and to help you get a sense for what this fundamentally new way of building audio experiences with AI can do for you and whatever it is that you're trying to achieve. And then just some housekeeping items before I pass it off to Ilan. The webinar is being recorded. You will receive a recording afterwards. The code that we're presenting today will also be shared with you. So you can pick up where we leave off and start building. And then, yeah, if you have any questions, drop them in the chat. We have a couple of people here backstage who'll be helping answer them. And then we also have 10 minutes at the end of today's hour to answer some questions live. But with that, over to you.
Cool, thanks, Pranav. Okay, so let's get started. So we have a lot of ground to cover today. We're going to start with a bit of an overview of the real-time API and just the history of the multimodality, like through our history. And then we're going to do a couple demos. Now, because we're covering a lot of ground and because we have such a wide experience in the audience, one of the demos is going to be very much from the beginning, and then one is going to focus a little bit more on interesting techniques that you can do on top of function calling. Finally, we're going to look at a couple best practices, and then we can do some Q&A. So with that, let's get started. So a little bit of an AI history lesson. Let's look at the evolution of multimodality here at OpenAI. So we started out with GPT-4 that could take in and text out. We didn't start with GPT-4, but this presentation does. We also trained it to be able to receive images, and this was sort of what the whole picture looked like. Now, if we wanted to have image outputs, it didn't natively do this. If we wanted to produce them, we would have to use other models in between. So GPT-4 would output text, we would pass that text into DALL-E, and then DALL-E would actually generate the image. For audio, it was also not natively supported, and so we had to do this three-step process as well, where, and this is actually how the ChatGPT voice mode used to work, is we would take audio, pass it to Whisper, our transcription model, that would produce text. That text would get fed into GPT-4, then GPT-4 would output text. That text would be given to our text-to-speech model, which would produce audio, and then the audio would be played back. Now, as you can see, this technically covers text, audio, and image input and text, audio, and image output, but primarily GPT-4 is only doing text in, text out with a little bit of image. Then we launched GPT-4o, and it changed the game for multimodality. So this is actually what GPT-4o looks like. It is natively multimodal. It can do text, audio, and image in, and text, audio, and image out directly without a need for intermediate models. This was true of the model right as we launched it. However, on the API, we started off just giving the ability to integrate with text in, text out, and image in, similar to like the previous version. However, we are now supporting audio in and audio out as well. So let's take a look at the two different ways that we currently allow you to interact with audio on the API. So on one hand, you have chat completions API, which we added audio to, and then on the other time, you have the real-time API. So chat completions API is simpler to use. It's a little cheaper, and it's also just better for, I guess, this like offline batch processing. It has streaming outputs, just like we did before in chat completions. It's a very simple single endpoint on the REST, like with REST API. It's very familiar. It's easy to integrate with like previous systems that you might have, and it's very manual. However, the real-time API is really meant for like live real-time situations, and so it's very low latency. It's made for like it's optimized for these like conversational interactive experiences. And it's best for when you're having like conversation with an agent or controlling an interface with your voice. So the streaming is actually now handled a little bit differently. It's done with WebSockets. We'll get to that in a second, but it supports both input and output streaming, which is different from chat completions. The API itself is a little non-trivial. As we'll get into, it has a lot of events, but you can actually build something that works with a very, very small set of them. Like I said, it's optimized for latency, and it has automatic voice interruption handling. So if a user interrupts the model while it's talking, this gets handled automatically. You don't have to do anything about it, and we will look at that in 1 second. Cool. So let's take a look at these three, like what these three communication methods look like. So the first one is just regular old chat completions. You have a set of messages, usually text, that you will send, and then you will receive back the response. And every time you want another one, you send and you receive. Now that we added audio, it's actually very similar. You have an audio recording, you send it, and then you can receive it back. Very familiar. This is how it's been done for a while. However, the real-time API changes this a little bit, where now we have this two-way connection where you can send text and audio and then receive text and audio interlaced asynchronously at the same time. And this is sort of what enables it to be such a fast, low latency API. So how does it actually do real-time? The answer is WebSockets. So let's take a quick reminder for what WebSockets are. They are this stateful connection used by the web, and they are powered by, you start a connection, you open a stateful connection, and then you send and receive events back and forth. These are the events that are supported on the real-time API. And as you can see, there's quite a lot of them. This is not, you don't need to use all of them to actually build something great. The reason we have so many is so that you can really, like once you're starting to get to production or handle like specific cases, you can like really dive deep and handle every single case that you might want. That being said, for the most part, you will only be using this subset event, which lets you handle audio in, audio out, text in, text out, and function calling, which is what most people want most of the time. If you only want audio in, audio out, you can actually build it with just these three events, and that's what we're going to be taking a look at right now. So this is how you would build, just using these three events, a very simple audio in, audio out experience. So you would start the connection to the API, then you would send a session.update, which includes your instructions, and then if you want, you can also skip that step entirely. And then you'll send the user audio in chunks in this input audio buffer.append. And then you'll get back a response.audio.delta. And that'll contain the model's response in the audio. I do want to call out, and I added this slide for myself, that even though the model will output both audio and text, and it'll do so natively, the API does support input transcription. So when you are speaking to it, we will give you a transcript of what you have said. However, this is not done by the model. It is actually done by Whisper. And so you might sometimes see that input transcripts differ from what the model actually understood. We're trying to make sure usually that it is the same, but if you ever see like a slight difference, that is why. We're actually using a different model for audio input transcriptions. Cool. So let's build it. Think when we do these sorts of educational setups, I actually really enjoy when somebody starts from scratch. So that's what we're going to be doing. I have a terminal here, and let me just make sure I'm in the right place. I'm going to be making a project from scratch. So I'll be using Next.js, not because we need the backend, but just because it's what a lot of people build with. So it'll be quite familiar. So start. This is just a little tool that I have to help me run commands, but we're doing npx create next app, and this will set up a new app for us with Next. So let's call it real-time from scratch, TypeScript, no ESLint, yes Tailwind, no source, yes app router, no turbo pack, no alias. For anybody who hasn't done web development before, there is a little bit of baggage to start learning, but hopefully this will like skim through. Ideally, you'll have some experience with this. This is the most standard way, or one of the most standard ways that people build on the web. Cool. So now we have this repo. And we can take a look at our app, and we have our code. So let's actually run this. Cool. So we'll run it, and then we can see here. What is it? 3,000. Great. Nice. So this is what it looks like when we start off. We're actually going to take all of this code and just delete it. So we'll return hello world. Cool. So this is how we're going to start off. Start off really, really simple, absolutely empty. As you can see, we have 3 lines of code. One of them is a bracket. So let's actually start building on the real-time API. So the first thing we want to do is set up like the basic interface that we want. So what we'll want is a way to connect to the API, and then a way to turn on and off our mic, right? And so here we'll add just a couple quick divs, and then we will add a button to connect and a button to toggle mic. Cool. So as you can see, now we have all 3. Let me just make these a bit prettier with Tailwind. So this is Cursor. It's a little bit of like an AI helper that helps us like code faster, and I don't want to really deal with styling. So now, ta-da, it looks a little bit nicer. Now, let's actually start dealing with some of the setup code. So we want to write this connect function that will deal with like actually us connecting to the API, and this toggle mic function that will toggle the mic on and off. Now, one of the hardest things about dealing with audio in the real-time API is actually not the API itself. It's the audio portions. And so dealing with like audio input and audio output is actually like a lot of code. So what I've done is, and I'll be sharing this afterward, but I've written a couple webhooks, or sorry, a couple React hooks that I can use to do audio input and audio output. There's many ways to do this, and it'll differ for your use case, but I'll be sharing those in case you want to use them as well. So I'm going to come in here and make a new, I'll call it hooks, and I'll add a use audio player. And I've copied this code. And so this code doesn't really matter. It's very, very complicated. All it does is it sends audio to the output. And I don't want to focus too much on that. And we'll do something similar for the input. So use microphone. And I'll grab this from where I had saved it. Great. As you can see, it's a lot of code, but you don't really have to worry about it. Now, the way we actually use it is much more important. And so let's set up mic toggling first. Just let's get everything out of the way that is not the real-time API. So we'll start by using the hook. And so mic will be, I believe it's is listening, stop listening. Cool. So now I have both my imports, start, stop. There's actually a couple more that I have to add. Cool. So just to quickly go over how this hook works, I have this variable called is listening that'll update depending on whether we're listening or not. Start listening, we'll turn it on. Stop listening, we'll turn it off. Add audio chunk handler. What it'll do is it'll tell the microphone like, hey, whenever you have new bytes of information, I want you to call this function that I'm about to give you with every new chunk. So that just will line up nicely with how we use the real-time API. So we've set that up. And now let's also use the audio player. So it was is playing, add chunk, and stop. Use audio player. Great. And so what the audio player does is it works very similarly. Essentially, it'll tell us whether it's playing or not. It'll give us this function called add chunk, which will let us give it one of the audio chunks, and it'll play it, and it'll like do all of the buffering, and then it can stop. Now, as you can probably guess, these two functions, the add audio chunk handler and the remove one, but specifically the add one, we will essentially be telling the microphone that every time you add a chunk, it'll be we'll be setting it to the model, and then when we receive one from the model, we'll be using the add chunk from the audio handler. Now, I just want to highlight, none of the code that I've written is related to the real-time API just yet. I just want to get this mostly out of the way so that we can get started. So let's actually get started with the real-time API now. The first thing we're going to do is open a connection to the real-time API. So we'll do const WebSocket equals new WebSocket, and the address is api.openai.com/the1 not audio transcripts /realtime. Great. So this is the URL for our WebSocket for the real-time API. Now we also support passing in a parameter that specifies what the model to use is here. And so we'll be doing that as well. And so we'll be passing this here as the model is GPT-4o real-time preview 2024-10-01. Cool. So now I essentially have the very, very basics for a connection. Now, you may be wondering, how am I dealing with authentication? That's a great question. I'm not yet. So we also have to pass in our API key. API key. So let's get back to this in a second. For now, I'm just going to make it null, empty. And then before I do this, I do want to call out, adding your API key on the front end is usually a very bad idea. The only reason we're doing it here is so we can do rapid prototyping, and this is why we allow it. But in practice, you won't really want to be doing this from the front end. So let's hop back in and set up the headers, and this is what they will look like. So we're specifying that we want to pass the key and the beta. These are just the required headers, and you'll find this in our docs as well. Cool. Now, the question is, how am I going to get my API key here? I'm not going to paste it in because I don't want you guys to use the key itself. So I'm going to be reading in from an environment variable. Now, I have prepared this like a file already for the environment variable. And so to do so, I'm just going to use .env which will read it in from a file I just copied over. I almost clicked on it, but essentially this .n file has my key in it. So we'll do .n with config, and then we'll import it as well. And we just to quickly need npm file dot. Great. So now we can run that again. Amazing. Okay, so now we have our basic connection. And we can actually almost start here. The way the WebSocket connection works, we want a persistent WebSocket, so we're going to have to make a reference. WebSocket reference. This is just in React, every time that you re-render a component, like it'll like call the function once again from scratch. So what we want to do is create a reference to WebSocket. This means it just won't be re-rendered each time. So we can just import use ref. Fantastic. So now we have this reference. Once we create the WebSocket, we can set it, and then we can actually do the fun stuff. So now we can set the onMessage handler. For now, let's just log it, right? So we should now have enough to see that we are creating our first connection. Doesn't like use ref. Oh, right. So the other thing about Next.js is we want the use client, since we're going to be using this just to disable server-side rendering. But as you can see, now we have a bit of a setup. And so if we set the connect button to the on click, we can set to connect. Then this should create an event. Great. So now I have created a connection to the real-time API. We're actually almost there, because all we need to do now is send and receive audio messages. So let's start by sending the audio messages, and that way we can actually see when we start receiving them. So to send them, we can use the microphone handler, right? So first we need to define a function, a handler to actually use. So I'll add a line here, and this is like all, real-time API stuff. So let me define a handler. Handle, what would it be? It would be, yeah, handle microphone chunk, right? So essentially what this does is we are telling the microphone what to do with each new chunk that it records. And let's also use callback. That just means we don't want to redefine this every single time. And we'll import this up here as well. I'll import use effect as well, since I know we'll need it later. Fantastic. So now we have handle microphone chunk. And what it does is, this is actually correct. What this will do, which was auto-completed, is every time the microphone records a chunk, it'll add a chunk to the player, which means I'll be playing back all the audio that I make, which is not what we want. What we want instead is actually to use to send this to the client. So we'll use the WebSocket, the current WebSocket, and then send the chunk. What is this chunk? Well, it'll be a encoded string of the type that we wanted. And so if you recall, if I go back to the slides real quick, the event that we wanted is input audio buffer.append. So we'll do type equals input buffer.audio.append, and then the audio itself will be a chunk. Now, what is this chunk? It's a string. It's a base64 encoded string. And now that we have this handler, we can connect it to the microphone. And the way we'll do this is not auto-completed. It actually knows what I want to do, but what this means is just run this once. And so when we run this once, we can handle add it to the microphone and then add it later. So now this should be enough to, actually, I'll jump in and do the listening portions as well. So we'll actually get into the most interesting part, which is handling the messages. So now, once we have the messages, we can decode this and we can log the data. This will be the actual event data. And then get and then we can switch the event. So switch the event type. And if the event type is response.audio.delta, then we can actually just play the delta. And now we should have everything that we need. We will use a start listening for the mic. Cool. So fingers crossed. Let's start our connection. Let's toggle our mic. Hello. Now we're getting some errors. Invalid request code. So what did we send? We sent a input audio buffer .append. Cool. So hello.
Hello, how can I help you today?
Great. So that was a little more complicated than the chat
Got it.
completions API. Oh, we can stop now. But the idea here is we have all the pieces, and the most complicated portions were not the AI portion, but instead the setting up the audio stuff. So I'll quickly go over what we did there. So we set this up directly from the front end. This is convenient, but it's unsafe because I had to load my API key directly there. Now, we can also use a proxy, and this means we will set up a server that essentially forwards all the requests between the front end and the back end and supplies the API key. This is definitely more secure, but it requires a persistent backend, which is actually not very standard in the industry. You have to have a different kind of server. Now, this is still not best practice. The absolute best practice is using a WebRTC provider like LiveKit. We'll be linking out to their resources later. But essentially, this is how you make a fully production-ready application. The abstractions change a little bit. You have WebRTC to the provider itself, and you use rooms instead of messages. It's a little bit different. It's a little bit, but it's more stable and more usable. So I'm actually going to skip the function calling part in the interest of time, and we're going to go directly into the second part of the demo, which is instead of implementing function calling from scratch, we will use function calling in a few different ways to do like real-time knowledge retrieval or live key extraction. Here I have a few examples where you can have generative UI, extracting key points, displaying comments, etc. For a precise guide of how to implement function calling, we have a few guides in our docs. We'll be linking to that, but we'll be starting from a template that you all will have access to, and then we can move from there. So let's talk a little bit about functions first. So in chat completions, you must always wait for a function to return. Now in the real-time API, you can actually call a function, and before it returns, keep having a conversation. And this is a little bit of a different threshold. And so some examples of handling these functions are a little bit different. Now, if you have like fast, quickly returning functions, and this might be something like a save note function or like get current time that like return immediately, you can just do it normally, right? Send the function, return it, add it to the conversation. If you're familiar with function calling chat completions, you'll handle this in just the same way. However, when you have long-running functions, it changes a little bit because now you have this space where you've called a function, you can keep having the conversation, but the result is not yet available. And this is actually not possible in chat completions. So how do you deal with this? Well, there's a few ways. One is you do nothing special. We've actually trained the model to be able to deal with these situations. However, if you want the exact behavior that you want, you might still want to handle it like explicitly. So number two is as soon as you call the function, return a pending result immediately. And what that'll do is tell the function, look, it actually returned. You're back in like a land of like normal chat completions. I know what the result is, but the result tells you it's not done. And later what you can do is inject your result as a user text message. And we'll see that in just a second. Number 3 is you can do this same thing, but instead of including the same thing, but instead of just depending on the prompt to tell the model what to do before the function has completed, you can add a second function that checks the status. And this just is sort of like moves function calling from being this like blocking synchronous operation to a non-blocking asynchronous operation that very similarly mirrors polling. So instead of starting from scratch, you saw how much work it was to set this up. And again, that's not because of the API itself. It's mostly because of audio and dealing with that as well. Let's use the real-time console. And so this is what it looks like. This is an open source repo. You can clone it. You can use it for whatever you want. And I would actually recommend for any new projects that you start, you probably start from here. It has a really, really nice abstractions. So with that, let's jump right in. So for this, I'm going to be making a new folder, and I'll actually be cloning the repo itself. So if I look for it here, this is the repo that I'll want. I'm going to use a slightly different string to clone it. Cool. So then I'll do, you can just do git clone. Amazing. And now I can go to the console and run npm start. Oh, install. Cool. So now this is ready to go. So now I can run npm start. And I'll have development server. It's actually going to be right here. Okay, so as you can see, it asked me for my OpenAI key. This is because the console itself also runs directly from the browser for convenience. Now, this is, again, you don't want to go into production with this, but for experimentation, this is totally fine. So I'll paste in my key. Hopefully you didn't get to see it too much, and we'll clear the recording. But now we have the console. And so for those of you who haven't seen it, let's do a quick view. I can connect to the API.
Hello, how are you doing today?
So as you can see, we send an initial message. Here you have the logs of all the messages we send. We send hello, and then I can say, pretty good. What's the weather in San Francisco right now?
Right now in San Francisco, it's about 16.4 degrees Celsius with a light wind of 4.1 kilometers per hour. How's that for your day?
It's great. And can you actually remember that my favorite color is blue?
Absolutely. I've made a note that your favorite color is blue. Is there anything else you'd like to chat about or need help with?
Okay, so this is the real-time console, and when you clone it, this is what you get out of the box. We'll be looking at the code in just 1 second, but I want to show how we have a couple examples of functions, right? As you can see, set memory is one of the very quick returning, actually, these are both quick returning functions, right? Get weather is a very fast API call. It'll take just a few milliseconds, and then it'll be supplied back to the model. Now, set memory, it has no return values. You can set the memory, and then it'll simply call the function and you can return immediately, regardless of whether you have finished or not. So what we'll be taking a look at today is how we can add, how we can make a personal assistant that can access your calendar and your emails. Now, I don't want to spend too much time on the integration portion of things, right? We're not going to build out the actual access to the emails or the calendar. We're instead going, I'm going to show you the interaction patterns that you can have with these instead. And so what we can do is hop back into the editor, close our existing tabs, and go to the page where we control everything. So this is the main page for what we're seeing here. Now I'm going to scroll all the way to the bottom, and this is where we are showing the functions that we have. And just to show that we're going to do something different, I'm going to comment this entire portion out. So now when we see, we just have the events. And in the interest of time, I'm not going to implement a UI for this. We're going to be mostly focusing on just the interaction patterns themselves. And if you want to make a UI for that, you can. So what this is going to look like is dealing with functions and asynchronous functions. So the client itself has this really, really nice functionality where you can give it the function schema that you want to use, but you can also give it an actual Python function that it will call when the model calls your function. And then automatically it'll take whatever you return and supply it back to the model. So this is like, this is part of our example implementation in the console. And this is why I recommend you start there. It has all these really nice constructs that you can use to get started. So as you can see, we currently have the get weather one and the set memory one. Let's look at adding one more. So we said email, right? Let's say that we want to add a new function here. Let's say we want to make a function. Actually, instead of doing this by hand, I'm going to hop into our playground. For real time, which you also have access to, because I want to use the add function and generate. And so this is a nice little feature. If you're ever writing functions and you're defining the schemas, you can instead use this generate feature that we have. And I'll say like, make a simple function, or I guess a simple function to, I guess it'd be like check to submit an email query, make it have only one input, the input query. Cool. And so this will give me the schema that I can use. So I'll just copy this and hop into here and give it the schema. This, we can talk about that later. So submit email query, and it submits, I can just say, use this when the user asks a question about their email, or simply a question about personal information. Okay. So query to search. Cool. So now I have this function. I'm also going to pull up the instructions that we passed the model. And this is being, these are the instructions that are being supplied. Again, you'll see all this in the console. I'll delete all of this. You don't actually need any of this. And I can say, you are a personal assistant when the user asks. Oh, look at that. Call this function before responding. Call this function immediately before responding. So what this will do is it'll just make sure that instead of telling me, sure, I'll look for this email, blah, 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 it'll actually call the function first, which will get it started. And then tell me, I called it. Which is just a little bit faster. Cool. So now this is all pretty standard, but now let's take a look at how we are actually going to deal with this last portion. So this is currently, okay. So this function, I can just delete the contents. So this was the previous function. It used to take, lat long location. Now I can just say search, what's the variable? input query, right? And so what it'll do is it'll, when the model calls this function, I can just call this function, or it'll call this function. I can do whatever I want here. So for now, let's simulate this interaction pattern that I was talking about. We are going to start some process that is going to take a while, but then return the function immediately. So, so we're going to use timeout. Cool. I actually just need set timeout. So what we'll do here is make it wait for 5 seconds. So this is a little quirk about JavaScript, but I'm going to return a string that says to status submitted. Okay, so here's what this looks like. Just to talk a little bit about what I just did. I made a submit email query, told the model how to use it, and then we'll start essentially a timer that will do something, but then it return immediately. It won't actually wait for this timer to finish. What this timer is doing is just saying like in 5 seconds, do something else, right? And so what do we want to do in 5 seconds? We actually want to do what we talked about before, which was update the model with the correct response. And so we can do, we can use the client real-time send user message content. Okay, so what I'm doing here is after 5 seconds, I'm going to send a new response, and I'll make that response sort of look like what a function response would have looked like. So I'll have result equals, and then we can just make something up, right? So I'll be like, you know, July 2nd, 2024. Now we just have to decide what question we'll be asking. But whatever question we ask, this is going to be the result. So let's give this a shot. Let's go back to the console and connect.
Hello. How can I assist you?
Hi, can you check when my last dentist appointment was?
I've submitted your request to check when your last dentist appointment was. You should receive the information shortly. Is there anything else I can help you with? Your last dentist appointment was on July 2nd, 2024. Is there anything else you need help with?
Okay, great. So what we saw just happen there is first it submitted the query. I actually stayed silent because I wanted to let it finish. But if I quickly just say like, you know, always speak in 2 to 6 words. Then I can do something like this. So I'll run this again. I'll say like,
Hi there. How can I assist today?
hi, when are my parents arriving from their flight?
Checking your email for that info.
Have you gotten there yet?
Please check your email for details.
Okay. So as you can see, this is actually one of the failure cases I wanted to highlight is what happens if while it's searching, you ask for an update. And in this case, it was a little confused. It didn't quite know what to do. You know, you can tell it in the prompt like, hey, you know, like if a user asks, how's it going? Like respond accordingly. But what you can also do is give the model a way to check. So what you can do is add a different tool called something like check last query status. And what you can have this function do is tell the model that it's going to use this function to check the status of the last query if the user asks about it. And then we will actually use no input variables. And then we can have input variables here, and that's okay. And what we can do here is kind of fudge it and always just return like still pending. So now let's take a look.
Hi there, how can I assist? What's on your mind?
Actually, let me increase the wait time from 5 seconds to 10 seconds, just to really show this.
Hi, how can I assist?
Hi, when is my next flight?
Checking your calendar now.
Have you found it yet?
Still processing. Please wait a moment. Your next appointment, July 2nd, 2020.
Great, so we gave the model a way to, still talking. We gave the model a way to deal with these like mid function call interactions by actually splitting it up into multiple functions. We're not gonna get to the context today, but I just want to show you mostly how this pattern works so you can implement it yourself. To wrap things up, or before we wrap things up, I have this reminder to mention Twilio. Twilio is actually the first way that I started using this API. It's a very fun way to interact with it. And if you want to do with telephony, they have a great guide that you can use to follow. So to wrap things up, let's go over some best practices. The first one is start simple. You saw how complicated it can get very quickly. So use existing tools and templates like our console. The second one is question your need for audio output. As you saw, I was waiting for the model to respond for a while. Sometimes you would rather see text than hear a response, or ask it to respond very shortly. But respect the user's time is always a good principle. Third one, I didn't quite get this, but real-time as an interface, not a workhorse. So the real-time models are very latency optimized, and so you don't want them processing large amounts of data. If you want it to perform a very complicated task, have it be the bridge between you and the computer, and have it interact possibly even with other models. And that way it's always around, it's always live, it's never busy, it's always available for the user to ask questions, kind of like a mouse. Don't block when you can pull. This is what we showed. If I had just created the function call and like stopped the conversation until it returned, it would have been like a very unpleasant experience. So let users ask, are we there yet? And then finally, we didn't quite get to this, but the model is also outputting a transcript of what it is saying itself. And it is happening much faster than real time. It's actually, you usually get the entire transcript of what is said before you actually start playing it back. Just not because it's slow, but because the actual transcript is so fast. And so you can leverage this for guardrails. Cool. With that, we have 10 minutes for Q&A.
Awesome. So yeah, we got so many questions from the chat, so thank you everyone. A lot of interest in building with the real-time API, so we're going to try and get to as many of them as we can in the time we have allotted. And if we can't get to your question, please feel free to reach out to your point of contact at OpenAI. I'm sure they'll be happy to set up a longer session for you to discuss some of these things with a team member. The first question, since we were talking about function calling quite a bit, is around like tool use. So there's a couple of questions here. I'll just bundle them up. Is there like a max number of tools that you can provide the real-time API? What have you seen work? And then one more tactical one around changing the role of the return text to be tool based on the response. But yeah, so those are two questions around tool use.
Yeah, that's both good questions. So the first one is how many, sort of how many tools you can have. The short answer is I don't think we have a hard limit, but you shouldn't approach that hard limit. You should always try to minimize the set of tools that you have available. This is true for our chat models. It's also true for our audio models. I'd say it's especially true for the audio models. They're like not quite as performant with function calling as chat completions. They're still quite good, but you want to make it easy for the model to know which functions it's calling. One tip for that is, other than describing in the function itself when it should be called, you can also guide it in the prompt. And so this way you can have multiple different functions. Maybe rule of thumb, try to keep it from 5 to 10. If you start to go over that, consider splitting out into different approaches where you might triage, update the functions as you go, etc. The second question was on like the role of the return. So the reason you have to emulate it with a user text message is because we don't allow two different tool responses. The first tool response you would like is the real one. You would supply pending, and this will tell the model, you haven't actually gotten there yet. Ideally, you'd be able to supply a second tool response for the same model. We don't currently support that yet. So the way you emulate it is with a text user message, and you like make it look like a tool.
And then some questions around prompting. I
Mhm.
know you went over that in a little bit during the demo, but any best practices on getting the model to continue to stick with your instructions? Some folks have experienced a degradation in like the model's ability to follow your instructions over sessions, over like turns in the session. So how would you suggest doing that?
Yeah, so the voice model, or the voice modality is fundamentally the same model as 4.0, but because it's a different modality, it's almost like our models are best in English. They're pretty good at other languages, but once you start to get like really obscure languages, they might not perform as well. Audio is almost like an obscure language. And so you might not expect the same performance, and the prompting might be a little bit more difficult. For example, I made the demo for the Wanderlust in Dev Day. Some of you may have seen this, but the prompts for that were actually quite large, just trying to give it a lot of examples. I think my best advice and what worked the best for me is few shot prompting. So give it a lot of examples of interactions and what it's supposed to do. It can follow those more easily than verbal descriptions, is what I found. This is true always, but especially true for audio.
Cool. Let's switch to session management for a bit. So one question is around contexts get longer and there's kind of like sometimes a misalignment between audio and text tokens as contexts get longer. Any sort of tips on how to deal with that?
I'm not entirely sure I understand that
Okay.
one. I'd say for the most part, if you're trying to manage the context to avoid prices, to avoid like large costs, I would not spend as much there. We are working very, very hard to get the price down, so you don't have to think about context management overall.
But in the meanwhile, like, are there ways to remove items from the context?
Yes, so you have full control over the context. It is easiest as if you treat it as append only, but we do have functionality to remove parts, to replace parts. You can essentially reconstruct it as you want. It's not as easy as like an array of messages, but it is more like a linked list almost, or you can remove and put messages as you wish.
Got it. And then a couple of like just general developer experience related questions, like what can we say about a Python SDK or SDKs in other languages? Yeah, if there's any updates on that.
We want to get out some SDK very, very soon. Or sorry, not very, very soon, but we very much want to do this. I don't want to commit to a timeline, but obviously we want to make it as easy as possible to use. And right now it is not. My recommendation in the meantime is there's actually been some really nice like open source community developed SDKs that you can take a look at. And then there's also like, once you want to start building something more robust, I think my recommendation would be like LiveKit or Agora, or some of these providers that we talked about earlier that deal with the WebRTC like middle point. Yeah, I think that's my answer there is we really want to get you an SDK soon.
And I know we didn't cover telephony much except for your little vignette there. There are some interesting questions on telephony, so I wonder if you have any thoughts on those. With telephony, like one of the sort of use cases is customer support and transfer and doing live transfers over. So any like tips on how to do that with the real-time API, so the context is preserved of the entire conversation as it gets transferred to a human agent?
Yeah, so that is actually the pattern that we explore in Swarm. If anyone is familiar, it's this like exploratory framework that we have, or repo mostly, just to show this like handoffs pattern. I haven't implemented this myself, but I know it's actually been experimented with. But you can swap out the system prompt halfway through a conversation. I don't know how well it'll work on audio, but it's really useful when you want to swap out like the personality. If you actually want to drive the conversation, etc., you might want to swap out the entire system prompt, which you could do with a system.update, but you might also want to send and reserve like user text messages to be almost like pseudo system messages, where while the user is having like a purely audio conversation, you as the developer can use the user text messages to send instructions to the model of like what to do next. And so, for example, you could swap out the system message to be a different persona and then send the system a user text message saying something like, you've been swapped to a new persona, adopt it, right? Just as a reminder. So I think that should work well. It's still pretty early days. I encourage you to experiment with it. The models will keep getting better. So hopefully this will get easier over time.
Cool. We have time for a couple more topics. First one is around handling audio interruptions that aren't part of the conversation, like echoes or background noise. Are there any things you can do with the API to minimize the impact of that?
Yeah, so we have, for automatic voice detection, we have tunable parameters that you can play with. And actually, if we go back to the playground here, let me bring it up. If we go to the playground, you can actually see some of the settings that we have. So you can like tune the threshold, tune like how much it'll wait before and after starting, tune like how long it'll wait. You can play with these settings to kind of tune how you want. But it's really nice that it's automatic for the most part. We're making it better as we go. If you want to do it manually, you can as well. You can disable it and do it yourself. But I would recommend just using it and tuning the settings.
And then maybe this can be the last topic, guardrails. You discussed it a little bit. What are the, and you know, the text is generated before the audio, so how can you kind of leverage that to maybe ensure safe outputs?
Yeah, so you know, it always kind of comes down to how you want to do these like guardrails and like what the guardrails actually look like. Actually, my recommendation is very often you can do a lot just in the prompting. I'd say the real-time model or like the real-time modality is maybe a little bit less receptive to like following instructions very closely in the prompt, but I'd say that is still where like you want your guardrails to be preventative, like not reactionary. And so you can also have reactionary ones, but that'll be more jarring for the user, right? Like if you have to make them wait, or if you have to like cancel a completion, you can. But to get into that a little bit, you get the audio and the text simultaneously. However, you get both way faster than real time. Like you get the audio way faster than you can play it, so you actually need to buffer it. But that's really beneficial for the text because you'll probably get like the entirety of the text before you play the first second of audio. And so you can always use that text to pivot and have like a default message or something if you really want to, or like in sensitive situations. That's kind of what I would recommend. Same best practices that go for chat completions, guardrails as to this. Yeah, I'm happy to do like a couple more if there's a lot. If not, we can wrap up.
I think we should probably, let's see if we have a couple more. I think we've got a lot of different topics. And just generally, right? Like maybe I've seen a couple of questions come through on this. How do you think about using the real-time model with like a model like O1, for example, leveraging the strengths of each?
Yeah, so that's a great question. That is sort of why I wanted to focus on this like long running tasks, is because if you can really master long running tasks in a way where you can interact with outside systems that might take a while to respond, you can all of a sudden start playing with models like O1 or other models where you start off a task and you have this like polling pattern where you can keep talking to the model, and the model can just serve as this like interface, almost like control point that just starts tasks and checks on tasks but doesn't do a lot itself. That's kind of how I would recommend this. And then if you ask it like a very complicated question, it could just pass that question along to O1 and be like, hey, I'm like going to work on this for a little bit, I'll get back to you. And then once O1 is done, it'll respond and you can supply the text. But that's kind of what I went with. Some of the best practices is try to keep the actual tasks for the real-time API very lightweight and use it more like a router or a cursor that interprets user intent and connects it to the right resources. but you can keep the heavy lifting for our chat models, O1, search, query, etc. Like you can have these happen outside of the model.
Cool.
Yeah, that's probably my biggest takeaway here is use real time as an interface, not as like the main heavy lifting model.
Awesome. Well, that's all the time we have today. Thanks,
Great.
Alan, for this amazing content here. And yeah, we'll be sharing out the recording, the code repos. And yeah, look forward to having you join us for the next build hour. Thank you.
Cool. Yeah, thanks. See y'all.